Hello and welcome once again to my channel. Today, subtraction by addition, which is also called the complements method. And this is taken from a website Math is Fun, and due acknowledgement to Mr. Orghu Bakchi, who first introduced this puzzle to me and encouraged me to make this small video, particularly if I can include how the strategy works, because that is absent in this website. So okay, a disclaimer is there that I don't recommend this for normal subtraction work, but it is still a valid and interesting way to subtract, and in some cases it may save time. Anyway, let us start. X minus y, say, equals to z. So I am subtracting y from x to get z. Fine. But we demand that instead of subtraction, we will be doing some addition to the same x and to get the same result z. So it looks a bit impossible, isn't it? Because if you subtract y from x to get z, that z must be less than x. Okay. But if you add something to x to get that z, then z is going to be definitely going to be greater than x, right? So it looks a bit impossible. We are assuming that all numbers are positive here. So is there any trick with this yc that I'm adding to x to get z? But mind that yc is not a negative number, so it doesn't resolve the problem. Well, before I go into the trick, let us quickly follow the steps. 3 simple steps it consists of. First, take the complement of the number we are subtracting, that means y. Then add it to the number we are subtracting from, that is x, and then discard the extra one on the left. So taking complement of y, adding to x, discarding the extra one on the left. Okay, and here yc is the complement, so that we are adding to x. And what is that yc? How to calculate that yc? Okay, actually the trick is here, that we are discarding extra one on the left, and that resolves the problem that even when I add something to x, it would not be greater than x. Okay, it should be less than x. How? So here the trick lies. Okay, let us see some example, but before that let us see how to calculate the complement of y. So the steps are: start at the ones position, skip over any zeros, and then for the first digit that is not 0, find what makes it to 10, and for all other digits find what makes it to 9. So for example, suppose your y is 172, then 2 8 makes 2 to 10, so it is 8, and for other digits it is 9, so 2 makes 7 to 9, and 8 makes 1 to 9. So the complement of y, we will call it yc, is 8 to 8. So example, we have taken x equal to 653 and y say 172, whose complement we have derived, and we are taking the subtraction to get the result 481. Fine. But we are demanding that we are adding the complement to x. That means 653 and 828 are added to give obviously a greater number. But then the third step is discard 1 from the left. So if I just drop it 1481, it gives you just the right result, 481, right? Well, calculating the complement, here is another example where we have to skip over some zeros. Example, say 1700. So skip over the 2 zeros on the right, and then complement of 7 is of course 3, and of 1 is 8 because it makes it 9. So 8300 is the complement of 1700. That's all. Okay. And in another case, what if the number we are subtracting has fewer digits? That means y has fewer digits than that of x. Say for example, 4567, 4-digit number, minus 56, 2-digit number. The answer is of course 4511. Then how we can make the complement? After taking the complement, we just fill any missing spaces with 9s. So let it be clear with example. So 56 is y. So obviously 44 is the complement. Now 44 is a 2-digit number, but x is 4567, 4-digit number. So that means 2 vacant position you just fill in by 2 9s, and now you add to get 14511, and then as usual discard the extra 1 on the left, and the answer is 4511. But the question, how does it work? What is the mathematical rationale behind this functioning? Well, let us go back to our example, 653 minus 172. Okay. Now x minus y equals to z. If I write that, if I add something, say 5 to x and then subtract the same 5, then it remains the same. So x minus y remains x minus y, but in the meantime we have added 5 and subtracted 5. So that we can do anytime. Okay. And with a little bit of rearrangement, the red colored 5 and y we have bracketed and minus 5. Okay. That means x plus 5 minus y, it could be anything other than 5. So that's why I am writing here anything minus y minus that anything, that 5. So minus that anything. So x plus anything minus y minus that anything, that gives you z. So in our example 653 plus anything minus 172 because it is y, and minus that anything is 481. Okay. Now deliberately you have chosen 1000 to be that anything. So that anything is 1000. Okay. That we can do. We can use any number actually. But what we are doing, we are adding something yc to x. And in this step we are adding actually these two. Right? Of course something else is here. So for example 653 plus 828 that we have added to get 1481. So it clearly shows that exactly 828, and that is this yc. So this is your yc. What we are adding to x is yc, right? Or in other words, that yc is chosen in such a way that if when added to the y, it gives you 1000, provided the main number is 3-digit number. Okay, x is 3-digit number. Then what does it mean? The discard 1 from left. So mathematically speaking, you are actually subtracting 1000 because it's 4-digit now. The original number was 3-digit, now it's 4-digit. So from the 4th position, it is 1, 4th from right. So that means you are subtracting 1000. That means 1000 from this 1481. Okay, that's all. And exactly that we are doing here. We are subtracting 1000. So taking the complements, first step, adding to x, second step, and discard 1 from left, the third step. And all these 3 are in this simple equation, and that we can we have the liberty to use 1000 here. Okay, so it would be a little bit more clear if I take a 4-digit number to start with as x, say for example 4567, and we are subtracting 56 from it. The answer is 4511. So again we can write x plus anything minus y minus that anything equals to z. Fine. So x is 4567 and anything minus y is 56, and result is 4511. Okay. Now deliberately we are putting 10000. That means 10,000. this red color is there because in comparison to the last problem, one more zero is here added, so that anything is added and subtracted here. Okay, so why 10,000? Because the digit x is 4-digit number. Initially in the earlier problem it was 3-digit number, that's why it was 1 followed by 3 zeros, but now it is 1 followed by 4 zeros, that is 10,000. So the same logic, that we are adding something to x and then doing something else also. So here the example, we are adding the complement, as we have shown earlier, that this is the complement of 56 and we are getting 14511, and that is exactly the YC. So if you subtract this, you will get this number, or YC is chosen in such a way that when added to Y, that is 56, you will get 10,000. Okay, now the same question, discard 1 means what? Of course, subtracting, this time it is in the 5th position, so 1 followed by 4 zeros, so you are subtracting 10,000 from this number, this 5-digit number. Okay, and that is nothing but we are subtracting here. So again, taking the complement, adding to x and subtracting, that means discarding 1 from left. All the 3 steps are very clear. I think you have enjoyed and got the fun of the beauty of mathematics. So thank you for watching. Thank you very much.